Okay, here we go. This one right here, the equivalent expression to this. The equivalent expression to this. Now, so what it's wanting us to really do is it's wanting us to tell what is this fractional exponent doing to this. Now, we can perform the power rule. Okay, so we're going to go ahead and we're going to simplify this down. Okay, so we're going to perform the power rule, which says that this 2/3 is being multiplied to everything in here. Correct? And so when I do that, this is going to be 8 to the 2/3 and x to the 6/3. Correct? Do y'all agree with that? All right, and so 8 to the 2/3, we're not going to do anything to it yet. Okay? And this x to the 6/3, what happens to 6 over 3?
Reduces to, I don't know,
What's 6 divided by 3?
3.
No.
2.
2. Okay, that's 2. Now, do you remember what a fractional exponent did? Here's what a fractional exponent did. Whenever I had something raised to a fraction, the top number was the power, the bottom number was the root. Okay? And so the power on the 8 is squared. The root on the 8 was cubed. Right? Was there a fraction left on the x squared? No. So what do you think that means about the x squared? Well, it already is, so since there's no fraction, then there's no radical, right? So this is really x squared to the cube root of 8 squared. What is 8 squared?
64.
Okay, so I have x squared to the cube root of 64. Now, you're going, I don't know anything about cube roots, and that's right, because you're going to really do that in Algebra 2, but let me show you how you can use the fractional exponents in your calculator. So, over here, can everybody see the screen like that? Can you see what I'm doing? All right, so we had initially 8 to the 2/3 power, correct? So I'm going to go 8, rooftop, which is right here, rooftop. That's going to give me the power, parentheses, 2 divided by 3, close parentheses. And I get 4. Is it a decimal? That means it's a perfect cube. And so, this right here is going to come down to x squared times 4. What is x squared times 4?
4x squared.
Very good. Very good. The only part about that question I don't like is we didn't talk about cubes, which we'll really do. But you can use the fractional exponents because you're probably going, why in the world do I have them? It's so I can use them in here. If you raise those to the fractional exponents, it'll take care of it for you. Because you probably didn't know the cube root of 64. And so, there's my answer.